Right, what I'm doing now is just centre drilling this blank, this die blank. I'm just taking it steady with a centre drill. I never go straight in and out with them. I just like to go in a little bit and then withdraw. Keep doing that till I get to the full depth. So easily broken the centre drills. Now next I'll drill it for the 26 thread per inch 7/16 tap. But I want to put a pilot drill through first, and then I'll drill through with the 11.30 tapping drill. Now the British Standard brass or British brass thread is an imperial unit base screw thread, and it adopts a Whitworth thread form with a pitch of 26 threads per inch and a thread angle of 55 degrees for all diameters, and it's often wrongly called British Standard brass, but it's not actually covered by a British Standard. Now the reason for adopting the 26 TPI is brass tube has relatively similar wall thickness irrespective of the outside diameter of the tube, so therefore as British Standard Whitworth depth threads are determined by the threads per inch, a lower TPI would reduce the strength of the tube, or it'd even cut through it. Now brass tube threads can be confused with the British Standard cycle thread, one of which is the most common, is also 26 threads per inch. Now the difference being the thread angle of the British Standard cycle is the same as the metric thread angle of 60 degrees. Well, I'm drilling it now 11.30 after pilot drilling the blank die. Now the reason I pilot drill first is that if you drill through with the actual size tapping drill, there's a possibility it could drill a little bit big if it ain't sharpened just correctly. So I prefer to just go through with a pilot, and then I know that when I go through with the final size drill, the drill hole should be okay. Now this is the tap I'm going to use. It's an old tap. Is this? It's I think made by Osborne, and this is the 7/16 by 26 threads per inch brass thread. Now it's, as I say, it's an old tap. It's the only one I've got, and that's prompted me to make this this die to go with it as a sort of a demonstration to show you how you can make a die if you're stuck for a die with a special size or special thread, one which you can't buy anywhere, or you'd have to have made to order, which could be very, very expensive if that was the case. Now when I do any tapping in the lathe, I usually bring my tailstock up with a centre in it, and then just apply a little bit of pressure, gentle pressure, put the die stock on, or even sometimes a spanner, and then as I turn the die stock or spanner, I just gently put pressure on the tailstock until the tap starts, and then just continue winding in ever so gently. When I get so far with the tap, I can release the tailstock and then just tap it in the normal way. Now this old Presto tap, it must be a little bit blunt. As I say, it's a very old tap, and it's not going through this die as easy as I would like. Although this type of material, gauge plate and silver steel, it's not the best of materials to tap anyway. In retrospect, I think I ought to get myself a spring-loaded guide but you can put in your tailstock, and it's also can be used in the drill. It does help with tapping. Well, that's it now. I'm through the die. That's going through quite easily now. Well, that's drilled and tapped okay, and the pins don't seem to have moved, although they shouldn't, because they were really hammered in tight. Now you need to chamfer the front and rear of the button die, and I'm using a large centre drill here. The width of the chamfer wants to be on this die probably about a 1/16 or perhaps a little bit more, and that provides lead for the threads, and it also provides some clearance at the rear of each thread on the die. This just then enables it to start cutting. If you don't have this, it won't cut. It's just a matter now of punching these small pins out. Well, I face the other side off now to enable me to centre drill there to put the angle, the 60-degree lead there on the thread. It's just a matter now of knocking the pins out, and then that'll complete that operation. All I shall do next is to split it. Normally you split these when they're hardened out, but I've found splitting it before it's less liable to crack, and I've always been successful with that. So what I shall do now is knock the pins out. Well, that's the pins knocked out now. Well, I'm just going to now split the die, and I would actually recommend you not to split it in the soft state. Leave it while it's hardened out, because I found that when I did harden it, it expanded a bit. It opened out, and it was a bit too tight in the die holder. It's never happened before. I've always split these in the soft state, but I think you're probably better not bother doing that and just wait while you've hardened it out and then split it. Well, I found a suitable slitting saw. This is 1mm thickness, and it matched the die, the commercial die here, so I decided to use this. But as I mentioned, in retrospect, you're probably better off not doing this, and use a fine grinding wheel, slitting disc to slit the die when it's been hardened. Now, when I did split the die, I also machined a small V groove at the top, which you need really to open the die out slightly when you're cutting a thread. And what it does is that the screw in the die holder just slightly expands the die to enable you to cut the thread a little bit bigger if needed. Well, this slitting saw sounds like it's out of true. I know the arbor's true, and the spindle and everything's running true, so I think this slitting saw's in need of a regrind. For some reason it's not cutting even. just now chamfering the split in the die. I'm just using this special cutter, which was used for a different kind of a job, but it's ideal for doing this small groove on the die. Well, that's done with. Next job now is to harden and temper it. Well, I've just finished drilling this on the dividing head, on the rotary table dividing head, and now the next job is to harden and temper. It's basically silver steel, although it's made out of gauge plate, which is basically same stuff. So what I'm going to do now is harden it. Now, when I was in engineering, I was always told right from the start that hardening silver steel is to get the temperature up until it just starts to blister. I've never known anybody mention that before, but that's what we used to do with ordinary silver steel rod. But whether it'll do it with gauge plate, I don't know. I can't remember, but it's going to be heated up anyway and then quenched in water. You can quench it in oil, but I don't think it gets as hard. A thin layer of oil on top of the water also helps to stop cracking. And also you can use brine solution, which is supposed to be even better, but I don't know. I've very rarely used brine. But anyway, we're gonna heat it up and quench. Now, talking about hardening and tempering, it just reminds me of the time when I first started my engineering apprenticeship in the early 60s. In 1963 I started work at a small company, General and Textile Engineers, and in this company we used to do a lot of hardening and tempering. It's only a small company, I think only about 20 fellas worked there all told. It was very small. There was a garage and a small machine shop, fitting benches, the usual, and a garage which was next door. Now the hardening and tempering was done in the blacksmith shop, and the blacksmith shop was not all that big, but it was well equipped, and it had a forge there which kept going all day long. Now on the cold days, those apprentices and some of the men, they used to go into the blacksmith shop for his dinner break, and we'd all sit round, we had his own little buffets and benches, and we'd sit there having his meals, reading the paper, playing cards, usual. And as I said, the forge was always kept going, so it was lovely and warm in there. Now in the blacksmith shop, there's on our, I think when I was sat in front of the forge, on his right hand side there was a large muffle furnace, quite a big furnace, and that also kept you warm, and that was used for shrinking large diameter shafts, sometimes which I had to turn on a big lathe, on a massive huge lathe, and these shafts could be 4 or 5 foot long and 4 or 5 inches in diameter, and I had to turn these shafts to a certain tolerance. Now they fitted into a thing called a backwash roller. Now, these were big rollers using the wool combing. They probably weigh 1, 2 or 3 tons, and I had to bore these out part way down so that these shafts that I turned would shrink fit. So they had to be warmed up in this big furnace, and then the shaft was inserted while it was still red hot, brought out, and it contracted. If I made a mistake, they're all hell to pay. But at the side of this furnace, or just a little bit behind, 10 feet behind where we sat in the blacksmith shop, there were another 2 furnaces, and these furnaces contain cyanide pots, big cyanide pots, and they used to carburise or soak these shafts. What were made, they were called fluted rollers, about 2 foot long, 3 foot long, and they'd soak these in these big pots full of cyanide,
and we were sat not more than 10 feet from these cyanide pots. We never bothered, oblivious we were to cyanide. And stacked up at side of these furnaces were large, like small oil drums, I should say, full of balls of cyanide, about that diameter. They're all over the place. They were stacked up. And when these shafts had been soaking for most of the day to get the depth, the case depth, they were quenched in a tank near the forge. And when they were quenched, they made a loud bang, and everything shot out, everything spattered all over. And all over where we sat, you could see spatterings of cyanide, where the molten cyanide had dripped off the rollers before they were quenched. And even when they were quenched, there were bits flying all over, and we were literally surrounded by cyanide, and we never gave it a thought. We never bothered, and we sat there eating his sandwiches, and they were surrounded by cyanide and open tins with balls of cyanide in it, and we're all sat there eating his sandwiches and drinking his tea, oblivious to it all. Well, we weren't oblivious, we knew there was cyanide there, but nobody seemed to bother. Amazing, we all weren't poisoned. Now, in the far corner of the blacksmith shop, there was a big cupboard on the wall, and in big words it says, "Antidote for cyanide poisoning." And at the base of that, there was a stream, a trough, probably I think from an underground stream that run through the shop. And you're supposed to wash yourself with all this if you've got any cyanide on you or anything. But in the cupboard, these antidotes for cyanide were old bottles. Old green bottles have probably been there since the beginning of the century, because the shop where I worked, the workshop, it was like a time warp. It was like something in the Victorian time. There were line shafting, belt driven machinery all over the place. The most modern machines really had war finish stamped on them. Big horrible lathes. I think most of them were called Ward Haggis Smith lathes. And I think there's only probably 2 modern lathes, or 3 maybe modern lathes that were up to date. But it was quite an interesting place, and it served me well in my apprenticeship, because everything was old fashioned, it was all hands on. And the amount of stuff I learned from these old timers that worked there, because they were nearly all old men, it was amazing. I picked up all sorts of stuff: grinding, tool making, fitting, shaping, gear cutting, milling, you name it, the lot. But I always think about that blacksmith shop with all that cyanide, and I've often wondered, even now, how we weren't all poisoned. Health and safety didn't exist. If health and safety had been like it was today, the place would have been totally shut down, closed. It wouldn't have been allowed to open, because the whole shop really was a hazard. There were castings all over the place. Now, these rollers, what I just mentioned, were case hardened to these rollers. Now, they were hard, very hard on the outside diameters, but in the core they were very soft. They were soft, and when they'd been hardened, sometimes us apprentices had to straighten them. They'd probably have a little bow in them, or not just true. And it was a horrible job. And one day I had some of these to straighten, and one of them would not go. I used a small press. It was I think a 35-ton press, hydraulic press, which you used to pump up to a big clock gauge. And I think this was from early in the century, from the 1900s. And I used this to try and straighten this roller between 2 V blocks and spin it. And it would not go, but I thought, at this moment, I'm definitely going to make sure it will straighten. I thought, I'll straighten it, I will. So I pumped it up, but the clock reached 35 tons, but it even went a little bit further. I thought, this will straighten it, and it didn't. It didn't straighten it one bit. All it did was just smash it in half. The thing broke, and it flew all over the place with such a bang. If anybody had been stood next to me, that would have impaled him. It would have gone straight through him. And that frightened me to death, did that. I always hated that job. But it was a great place really for learning. You couldn't beat it. All the old-fashioned methods and what the old timers used to use, and it were amazing. But blimey, it was such an old-fashioned place. But well, I hope you found that a little bit of interest. It's just a bit of useless information. So now I must get on with this hardening. I've got some water here ready. I'm just going to use ordinary plain water. And I'm going to use my Sievert gas torch.
Now I'm just placing a couple of small fire brick cubes behind this blank die, just to reflect the heat back. I'm trying to not get the flame directly onto the die where the threads are. I just try and warm it up from the sides and heat the fire brick so that the radiant heat gets the die heated up to the correct temperature for quenching. Now hardening silver steel or gauge plate, it should be hardened at cherry red. That's approximately 770, 790 degrees centigrade. If you get it to a nice bright red, cherry red, that should be near enough for hardening it. One thing I must mention, don't forget to drill the two small dimples at either side of the split on the die. I'd forgotten almost, and at the last moment I drilled them off camera. I'm not getting the flame directly onto the threads themselves. I'm just heating it up gradually from the sides and using the fire brick to bring the temperature up. I don't want to impinge the flame directly onto the threads. Well, it's about the approximate temperature now for quenching. It's just a nice bright red. I'll get it into the water quickly and keep moving it about. You need to move it about really when you're hardening anything. You don't want to just drop it in and leave it. You need to agitate the oil or water.
There's any cracking now. Well, that's hardened out okay. It took a little bit longer, did that, because I didn't want to get the flame directly into the threads. I was, if you notice, I was going round the edge, and that's the best way. You don't really want to impinge on the actual threads themselves, although it will get to the correct temperature. But direct flame is better kept away from fine threads.
Well, it's hardened out okay as this die. It's almost like cyanide hardening with the fancy pattern on the front and rear. The file won't touch it, so that's a good sign. What I need to do now is polish the front and rear face up and get it ready for tempering. I'm aiming for a straw colour, not a light straw but just slightly darker. I found that works better. So that's the next job.
Now tempering can be a little bit tricky to get to the correct colour. Direct flame on it is not really desirable, and what I'm going to try and do is just warm from underneath so it heats the fire brick and the heat transfers through, and hopefully that should do it. I'm going to change the nozzle because this is far too big for tempering. This is the smaller Sievert nozzle. Right, so here we go again.
Now, for some unexplained reason, I've lost the video where I was tempering the button die. So what I've done, I've made up a small piece of silver steel with a hole in the middle. I've hardened this out like I've just done with the button die, and I've polished the surface. And I'm going to temper it the way I did the button die. Now I'm aiming for a straw colour. Just slightly off of light, just slightly darker than light. What I'm doing is not having the flame directly onto the sample. It's just going to be from below. As I mentioned earlier, I just heat up the fire bricks so that the heat rises. I think that this is a better way really, instead of having the flame straight onto the part you're trying to temper, and the heat will just rise up, and it's just a matter of keeping an eye out for the changing colour. And as I say, it's a pale straw colour what I'm heading for, and as soon as that's approaching that colour it'll be quenched, and hopefully that should do the job. You've also got to be pretty quick, because if you dwell on it, the temper colour will continue, so you've got to get it quenched as quickly as possible. Well, it's just starting to change now as the colour. I'm just aiming for a straw, just slightly off light, a little bit darker than light, not much, and that should do the trick. And straight into the water and quench. Don't hang about, get it straight into the water. And that's the temper colour what I was aiming for. As I say, if you leave it too long before you quench, the temper will change. So you've got to really be quick. Now this operation, what I'm doing is not necessary. You don't have to do this, but I just like to touch up the angle, the cutting angle. If you got your pitch circle marked out correctly and you've chamfered the front and rear, there's no need for this. It's, as I say, it's just my preference. I just like to grind up just touch up the angle there. Mind, if you do have a problem with it not cutting correctly, you could always just do what I'm doing here and just relieve the angle at the front of each thread, and that will give a little bit more relief, and that should cure the problem. But you shouldn't really need to do this.
Well, now I've got the die in the holder, and I'm just now going to see how it performs on a piece of brass.
Now here's a view of the die in its holder, and if you notice the split has opened quite a lot, and I don't know why it's done this. It's never done it before, so I would recommend definitely if you're going to split the die, split it after you've hardened it. In fact, you don't even have to split the die really, but if you don't, you won't have any that little bit of adjustment.
And there we have it, and that seems fine to me. The best way to test this is to actually get a piece of material and tap it, and then see how that screws into it. And also it's running true, so that looks okay. I think I'll try it on a piece of steel next.
We're just now drilling a piece of brass, and then I'll tap it with the 7/16/20 tap, which I used to make the die with, and then we'll see how it fits on the piece I've just screwed with the die. I'm just now trying the piece which I screwed with the die, and it's a little bit on the tight side, so what I need to do really is to put the piece back in and put the die over it again, and just close it up slightly. That's the reason why I like to have a split die. You've got that little bit of adjustment. It enables you to close it up a little bit and take a little bit more off if the thread's tight. Well, I've just closed up the die slightly, so I'll just take a little bit more off the OD, and then I shall try the nut again what I've made. Well, that seems to screw in and out all right. Not too bad, isn't that? Not overly slack and not overly tight. I think we'll call that it.
Right, we shall try it now with a piece of steel, but I think I'm going to need some cutting compound on. Well, it seems to be cutting fairly easily, does that? 7/16 diameter. Really, this holder is a little bit short on the handles. Yeah, it needs to tighten up a little bit. And that's cooked quite nice and clean. We can't try it in that because it's not deep enough. We shall just chop that off.
Well, that seems to screw on okay. No problem with that.
Well,
I think
I'll
call that a winner. It might be a little bit slack actually. I might have taken too much off by closing the die up. As I say, you really do need a slit in a die so you can open it or close it to suit the job.
That's just normal anyway.
I think that's okay. Well, that seems to be running true enough. That's the steel one. I think I'm going to call it for that. That looks like it'll do the job.
Homemade die. Well, I think that seems to work all right. I think I'll call that a success. The only thing I would do if you do happen to make one, which I doubt if anybody will want to make a die, because you can buy dies just about in every size, but as I mentioned, if you need a special size one, this is probably the way to go. There is a different way of making them, but this is the way I've used. And another thing, I would probably not split it. I would leave it solid, because you'd probably be okay using the die anyway without having it split. I found that on this particular die it did spring a bit. It opened out a little bit more than I've experienced before, so I'll probably leave that while it's hardened and tempered, and then use a small slitting wheel and just slit it that way. So we'll call that job done. I hope it was useful. I hope you found it of interest, and it might be handy if you're looking for an odd size thread, if you're stuck, and that's probably the way to go. If you had one made special to order, it probably cost a lot of money, and if it's just for a one-off job, well, this is probably easy to make your own. You're not limited to size. You can make it any size you want, really, but I think probably inch diameter is probably about the limit. But Well, I hope you found this of interest and helpful, and once again, thank you for watching.